Okay, today we are going over 11.1 mathematical patterns, and this is the start to chapter 11, which is on sequences and series. So let's take a look here first at what a sequence is. And a sequence is just an ordered list of numbers. Okay, so some patterns can be described with a sequence. So we're going to be looking at, throughout this chapter, different types of sequences, and mainly we're going to be taking a look at two different types: an arithmetic sequence and a geometric sequence. Okay, and then within each sequence we have terms, and a term is just a number in the sequence. Alright, so for this sequence here, which is just an ordered list of numbers, we need to describe the pattern. So when we describe the pattern, we want to look to see what's happening every time to get to the next term or the next number in the sequence. So here we can either say that to get from 243 to 81, 81 to 27, and so on. So each time we are dividing by 3, or that's the same as saying multiplying by 1/3. That's the same thing. Okay, so we need to find the next 3 terms. So we can continue here. So dividing by 3 or multiplying by 1/3. 9 divided by 3 is a 3. Divide that by 3 again. 3 over 3 is a 1. Divide by 3 again. 1 over 3 is 1/3 or 0.3, repeating. And then it continues on. So as of now, this is just called an infinite sequence because it keeps going on and on. Okay, another one here. We have to again describe the pattern. So to get from 27 to 34, 34 to 41, 41 to 48, we keep adding 7 every time. So we're going to just write add 7. So 48 plus 7 is 55. 55 plus 7 is 62. And 62 plus 7 is 69. And those are the next 3 terms in this sequence. So moving on here, we want to look at generating a pattern. So it says, suppose each student in the class has a conversation with every other member of the class. What is the minimum number, the least amount of conversations required? Make a diagram to represent the conversations. So this is looking at one person. So this one dot is one person. So assuming that this one person is not talking to themselves, we have 0 conversations going on. If we have 2 people, then we're going to have, if we just connect this here, 1 conversation. 3 people, we'll have 1, 2, and 3. 3 conversations. All of them are talking to each other. Okay, 4 people, we're going to have 1, 2, 3, 4. Then these 2 have to talk. 5, and these 2 have to talk. 6. That's 6 conversations happening. 5 people, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 conversations going on between 5 people talking. So if we look here, we can look to see if there's a pattern forming. So if we're looking at what we're adding, to get from 0 to 1, we're adding 1. To get from 1 to 3, we're adding 2. To get from 3 to 6, we add 3. To get from 6 to 10, we add 4. So if you look at the pattern here, we're adding 1, then we're adding 2, then we're adding 3, then we're adding 4. So if there's 6 people, then we can continue this pattern by adding 5 to this next one, which should give us 15 conversations. So it wants to know which of the following formulas can be used to find the pattern. All 3 of these are explicit formulas, and we're going to go over what an explicit formula is in a couple minutes. So if we plug in, for example, one person would be your n. If I plug in 1, I should get 0 conversations. If I plug in 2, I should get 1 conversation. If I plug in 5 as n, I should get 10 as my conversations. So we're looking at, okay, if we have 5 people, then n is going to be equal to 5. N equals 5. And I know that I should get 10 as my number of conversations because we just showed that in this diagram. So let's look to see which equation, which explicit formula will give us the correct one. So we can plug in 5 for our n and see what we get. 10 minus 3 is 7. Therefore, that does not work. Plugging in 5 here, 5 times 5 minus 1 minus 5. So I have 5 times 4 using order of operations, PEMDAS. 20 minus 5 is 15. That does not work because we need it to be a 10. So let's try this one here. 5 times 5 minus 1 divided by 2. This is 5 times 5 minus 1 is a 4. 5 times 4 is 20. Divided by 2 is 10, which is what we wanted. That's the number of conversations that occur when there are 5 people. C is our correct answer. And we're going to learn later in in later sections here, we're going to learn how to find this explicit formula. Okay, moving on here, this is called the Koch snowflake. So what you're doing with this is you're taking this one line segment and you're going to replace it with these 4 line segments. So see how we're replacing this 1 with 1, 2, 3, 4 segments. So the first figure only has 1 segment. The second figure has 1, 2, 3, 4 segments. Okay, the third figure, we know that each segment needs to be replaced with 4. So this first one here needs to be replaced with 4. 1, 2, 3, 4. This one here needs to be replaced with 4. 1, 2, 3, 4. Sorry, my bad drawings. This one here, again, replace it with 4. 1, 2, 3, 4. And finally, this one here, we replace it with 4. 1, 2, 3, and 4. So each one segment became 4 segments. So you can count them and come out with 16. Okay, I'm not going to draw the next one, but if you see the pattern that's happening, we're continuing to multiply every single one times 4. So 16 times 4, the fourth figure will give us 64 segments. So as one of your assignments, what you have to do is you're going to take an equilateral triangle. Here's an equilateral triangle, and we should know that from geometry how to make an equilateral triangle using our compass, which you would just open up your compass and then you can draw your quarter of a circle arc and then leave that same opening up and start that point here and make your quarter of a circle again, and then it will give you this point here and you'll make your equilateral triangle. Okay, so from your equilateral triangle, each one segment is replaced with these 4. 1, 2, 3, and 4. And then it'll form this. Your assignment is to go up to this third one here. So this is the one you have to go up to. this third one. All right, moving on here, we're going to take a look at what term it's representing and the subscripts. So if we have the first term is going to be represented as a sub 1. Okay, so a subscript is telling us what term it is. Again, the second term is a sub 2, a third term, a sub 3. Then we're going to mainly be using these two here. A sub n is going to be your nth term. And a sub n minus 1 is going to be the term before a sub n. Okay, so this is going to be the main one that we're finding. A sub n minus 1 is going to be talking about the previous term. So we're going to be using this one a lot as well. So if we have a sub n, the previous term from a sub n is a sub n minus 1. Okay, so let's talk about, we're going to have two types of formulas here. We're going to have the first one we're going to learn, which is the recursive formula. And a recursive formula defines the terms in a sequence by relating each term to the ones before it. Therefore, you need to know the previous term. And we just talked about what the previous term is identified as or represented as. This is how we represent the previous term, a sub n minus 1. Okay, so if you have a sub n minus 1 in your equation, you know it's a recursive formula. That's giving it away. A sub n minus 1, that is a recursive formula because you need the previous term. Alright, so let's take a look here. The first thing is it wants us to describe the pattern that we see here. So the sequence 2, 4, 6, 8, 10, that should be pretty obvious as to what's going on. We should see that each time we are add 2 to the previous term. That's what we're doing here. We're adding 2 to the previous term. Okay, the next thing is we need to write the recursive formula. So we're going to say a sub n, which means the term that we're finding, whatever term it is, we're going to find that by taking the previous term. The previous term is denoted as a sub n minus 1. So we're going to take a sub n minus 1, and we're going to add 2 to that. So plus 2. And this is my recursive formula. That's all it is to it. Okay, so then you can use the recursive formula to find the 6th and 7th term. So this is the first term, second, third, fourth, the 5th. So the 6th term, a sub 6, will just be the previous term, which is a sub 5 plus 2. So a sub 6 is therefore, well, a sub 5 is 1, 2, 3, 4, 5. A sub 5 we already know is 10. Plus 2 is 12. All right, moving on. Now we're going to talk about the explicit formula. So sometimes you can find the value of a term of a sequence without knowing the preceding term. Okay, so that is called the explicit formula. So an explicit formula expresses the nth term of a sequence in terms of n, meaning you do not need to know the previous term. So recursive formula, you need the previous term. Explicit formula, you do not need the previous term. All right, so here's an example of an explicit formula. So a sub n is equal to 2n plus 5. They're telling you this formula. And we want to find the 7th term. So the 7th term is denoted as a sub 7. So to find the 7th term, a sub 7, you're going to plug in 7 for n. and evaluate. So 2 times 7 plus 5. 2 times 7 is 14 plus 5 is 19. And that is your 7th term. So the explicit formula is much easier to use, especially when you need to find, say, like the 100th term or even the 20th term. Okay, because then if you're finding the 20th term, you just plug in 20 for n, and you wouldn't have to list the first 20 terms in the sequence. Okay, so now here we're going to determine whether the formula is explicit, where you do not need to know the previous term, or recursive, where you need to know the previous term. So we should remember that if it's recursive, we know it's going to have the previous term in it, which is a sub n minus 1. So this one should be giving it away already because it has a sub n minus 1 in it. So therefore, we already know that this is a recursive formula. This is a recursive formula. Okay, so a sub 1, they're already giving us. They say the first term is 3. All right, so let's find the second term, a sub 2. So a sub 2, here's the equation, is going to be 2 times, remember a sub n minus 1 means the previous term. So the previous term, the term before a sub 2, is a sub 1. And then plus 3. This is how we're going to find the second term. So we already know a sub 1 because they told us a sub 1 is equal to 3. They're going to have to tell you that if it's a recursive formula. So a sub 2 is equal to 2 times a sub 1 is 3 plus 3. Using order of operations, we get a sub 2 is equal to 6 plus 3, which is 9. So our second term is 9. So I'll write that here. A sub 2 is 9. Okay, now we're going to find our third term, a sub 3. So a sub 3 is going to be 2. We're still using our same recursive formula. A sub n minus 1 means the previous term. So the previous term from a sub 3 is a sub 2. And then we have plus 3. So we have a sub 3 is equal to 2 times a sub 2, which we just found, is 9. And then plus 3. 2 times 9 is 18, plus 3. 18 plus 3 is 21. So that's your third term. A sub 3 is 21. So to start this sequence, we would write 3, 9, 21, and so on. Okay, this next one here, there is no previous term, and it does not tell us what the first term is equal to, just like this one did here. So therefore, this formula is an explicit formula. So to find the terms for an explicit formula, if I want to find the first term is a sub 1. So all you're going to do is you're going to take n and plug in 1 for the first term. We do 2 times 1 squared plus 1. Okay, 1 squared is 1, 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. So the first term is 3. Let's find the second term, a sub 2. A sub 2 is, we're going to plug 2 in for n now. So 2 squared, and then plus 1. So I have 2 times 2 squared is 4, plus 1. So I have 2 times 4 is 8, plus 1 is 9. So far we have 3, and then 9. Okay, and then a sub 3, we're going to now plug in 3 for n, because we're finding the third term. 3 squared plus 1. Remember, do order of operations, do your exponents before you multiply. 2 times 3 squared is 9, plus 1. 2 times 9 is 18, plus 1 is 19. So our third term is 19. And then you can find more if you needed to find more. With the explicit formula, if it asked you to find the 100th term, you would simply just plug in 100 for n and then solve what that would be. If it wanted you to find the 100th term in this formula here, that would be pretty tedious because you would have to list the first 100 terms. And that is 11.1 mathematical patterns. Thanks for listening. Bye-bye.